Alright, so you're ready for this super interesting and cool bit, right? Boop. Maths. This should take me not very long. I'm hoping it doesn't take very long. It's multiple choice, you see. But we do have some maths, and I'm like, hey, let's do that. Hey. Oh no, why would you even do that though? File system, please. Oh, my files, they don't like existing. Okay, we got it. We got a file. We got one. Okay, and we can now fill it with answers for maths. Right, where's the calculator? Here it is. Got the calculator. Do you hear that? Do you hear that? Wait, let me do it again. What? Oh! Wait. Very satisfying calculator noises. Calculator ASMR. That'll be my next video. It won't, I'm kidding. I'm not doing calculator ASMR. Go away. Right, what's the question anyway? Should we actually have a look? Find partial derivative of the following function. Oh, okay. I mean, sure. Well, if you differentiate sine, you get cos. So it's not them. It's not that, and it's not. Do you see what I mean about this maths sheet? Just eliminated all three other possible answers. Pretty sure. Let me have a look. Yeah, that looks right. Yeah. All you need to do is read the first three letters here, and you know it's not any of these. Aren't these both the same? Oh, they swap the x and the y around. Oh. Okay. Let me just check what a partial derivative is. Because I'm not sure I actually did them anyway. That looks fancy. Should we pick one of these and see what it says? I feel like you just differentiate it with respect to both x and y and then put it in, you know? No, I don't want explanation. I want an example. You know what's good? Google Images. Let's see if we can find an example. Like this one. What have we got here? So what? When you differentiate it with respect to y, you get 9x. When you differentiate it with respect to x, you get 14x to the 6 plus 6, so 9y. Yeah. Yeah, it's the thing that I said it'd be. Yeah. So we've checked our answer now as well. Even better. Right, next question. There should be 5 of these. Yeah. Alright. You still could have done that one in about 3 seconds if I didn't bother to check my answer. Right, what's the next one? Let's see. Upside down triangle. That means like all or something when I know it, but clearly not here, so that's fantastic. Yes, F for fantastic. Marvellous. Find fantastic of the following function. Do you think it means partial derivative again? Do you think it does? What are the chances that it does? It kind of looks like it, huh? Should we copy and paste this thing into Google? See if it says partial derivative or something. Ooh. The gradient vector. Let's have a look, eh? F y equal that. Fine. Okay. Wait, what are we meant to be doing? Oh. Okay. The gradient, just the vector of partial derivative. I said it with. Oh! Didn't I say? I said. I did say, didn't I? I said it'd be the same thing again. Dear. Alright then, so what? If you differentiate it with respect to x, you got y plus, I guess that'd be minus zx or something, right? Apparently not. That's not an option. Oh wait, no, there's more here. Oh, well, I didn't see where the comma was. I thought the comma was here. So yeah, there's that. But wait, this is the only one with minus zx in it at all. This one doesn't have an e. This one doesn't have an x, and this one doesn't have a z. So what? It's got to be this one. I think it's got to be. Oh, they need to make their options a bit better. Okay, let's check though. So this is when you differentiate it with respect to y. Yeah, that looks correct. And when you differentiate with respect to z, you get yeah, that. It's kind of silly, huh? It's got to be D though, isn't it? We'll put D. Alright. Question 3. Calculate the total derivative of the following function. Total derivative? Ooh. Oh. Oh, I see. Okay. Oh, I see. Look, because it's got 3 things anyway. So it's like you do like a table. I still have not done this before. Probably skipped the lecture that all this stuff was in. But I'm thinking this is just like a table, right? So you've got like x, y, z, and like 1, 2, 3. This is 1, this is 2, and this is 3, right? And then so like the first one with respect to x isn't that, is it? No, it's not. It's this. Okay, we've only eliminated one answer by doing that. It's B, C, or D. Okay. But like you do the first one with respect to y, then it's 0, right? That's why they've all got a 0 in. See, this is what I'm thinking. Unless this is meant to be that one, but none of these are zeros, so yeah, it's not that one. This is not bad. And then if you do this with respect to z, you get sine x. Yes. Still no eliminated. We're actually having to figure out the question in order to get to the answer. This is going well. So where are they different? These 3 bottom ones. Different in the middle, different on the left. Oh, we're actually gonna have to do all of them to narrow it down. Well, except for the zeros. Okay, so what do we need? The middle one, differentiated by y, is sine x. So it's not b. Alright, and then what do we want? What's this one? The middle one differentiated by x, right? Which is y cos x. Okay, good. So, still not difficult, but at least we had to do the question. We actually had to do the question in order to get that one. Alright. Question 4. Consider the following function. Find directional derivative in the direction vector. I feel like they shouldn't have said direction twice. But sure. At 0.11. What the hell does this mean? What's a directional derivative, bro? Why do I need to know this? You ready to copy and paste it into Google again? Oh, I didn't mean to put E at the front. Okay. Directional derivative. We've got a function with two things in it again, and then we want it in a certain direction at a point. Okay. Ooh. The rate at which the function changes at the point that in the direction u. Oh, that kind of makes sense. How do you figure it out then? What? What? Oh, you just multiply each partial bit by its. If that's actually the case, this is quite an easy question again, huh? So let's see. If you differentiate it with respect to x, you're going to have. Oh, this is getting difficult to do in my head now. I guess. Oh wait, that's not a multiply. These are minused. Huh. That's interesting. Slightly interesting. Let me think. How would you how'd you do that? Because it's like a divide, right? I mean, it is a divide, but like, you know what? Let me bring up Paint. I wasn't going to bring up Paint in this video, but it might be easier for me to explain it to you guys. And if I am going to record this stuff, I might as well at least explain it sufficiently well. There we go. Paint. Of course, realistically, I probably should just not explain this. Not record this. But so look, what I'm thinking is that E thing can be rewritten like this, and then you do with a divide, right? And then you've got right. I'm pretty sure. Wait, I need a method of switching the paint off. It'll be there the entire rest of the stream. Paint is never going to disappear. Okay, there you go. See, look, right? You got that little function there. That could be rewritten like that, right? That's what I'm thinking. But then look, see, these are minuses, right? So then that can be rewritten like this. That's an awful E. Like, I know it's Paint, but that's awful. Right? Kind of like that. Oh. Got the squared. Can't it? I feel like it can. The only thing I'm thinking now is surely that would just make this, because then you could rewrite it back like this. You've just removed the negative off here and then you put it at the front instead, which I'm thinking is not correct. So in which case I've probably done something wrong, you know? Oh yeah, because I put it on the bottom of the fraction. Oh, yeah, I put it on the... Yeah, it should be at the top of the fraction and they both go to the bottom. So then this should be like this. That's the problem. That's what I've done. Wait, did I even bring paint back up? No. There you go. Should be like that. That's the issue. Yeah, no, see, now it makes sense. Yeah, yeah, okay. Alright, in that case, would this even have helped anyway? I don't think it would, to be fair. I was just kind of doing it. I just need to differentiate that, you know. Well, anyway, let's not have paint for now. Paint's gone. Wait. This still thinks it's here. There we go. Paint's gone. Okay. Now we've got, what have we got here? So, what am I actually trying to do here? Not sure, I guess. I'll just differentiate them. That's the point. I'm just trying to figure out how I do that, and I haven't got nice options to work out, because I've got to actually plug values in. But you're only timesing it by 1 anyway, and you're substituting 1 in for the first one. I mean, right? For this, and this, you multiply it by 1 and substitute 1 in. So we want something that looks like this at the end, right? Let me grab out the calculator. It's still here. So let me see. Let me have a test. So what's a good guess for differentiating that with respect to x? It would be... I'm thinking I haven't done this in a while. This is just going to be like a constant almost, right? You just divide it. So this is just going to stay, right? So, but it's still a point with 1. So on the bottom of the fraction, because it's a minus, right, you're always just going to have e to the power 5, right? Right? Probably. And then on the top, I guess you would have minus 2, because you would put that at the front here, right? Minus 2. And then, but you've got the squared though, that's the only thing that I'm wondering. Wouldn't that make it a 7 on the bottom as well? I know a good idea. Because I'm just thinking how to actually do this bit, because it's been a while. Let's see what this says on the matter. Did that type it right? Yeah, I just want to see what this is. So I've got something to work with, you know? There you go. I guess, oh yeah, you just use chain rule, don't you? I guess you just use chain rule so that'd stay the same. But you shove it down here. But you differentiate it. And then multiply it by that. Differential of this is minus 4x. I mean just of this bit. It's minus 4x, yeah? So then I guess you shove the differential down here. Oh wait, no, because e to the x is e to the x. So if you're just set with respect to this, it'd just be e to that. And yeah, there you go, chain rule. Alright, well at least I've managed to explain why it did that. So given that, and then this is just going to be on the bottom of the fraction all the time, you're going to have that over the other thing. Wait. Yeah, so you're going to have this divided by the other thing. The e to the minus 5 thingy. Yeah. The squared doesn't matter because it's only squaring 1 anyway. So you would have 7 on the bottom. So it's one of these top two. And then yeah, we don't even need to do the second part because different numbers on the top. So what would you have? You would have minus 4 on the top. Right? Times that by 5. See, I think it's minus 20. No, it's obviously not because that's not an option. So I'm missing one somewhere. I'm missing one. It's probably, it's a thing, it's got to be a multiple of 4, right? What I'm thinking anyway. Because of that. And 14 isn't. So I think it's A. But considering I haven't done this, I haven't done this. Maybe I should do that just to see what number I get for that one. See if that helps out, because they are different. Alright, let's do the second one then. Now this one we would multiply by 2 afterwards. Oi! This one is this multiplied by 2. Pog? Pog? Maybe? Pog? Okay, let's do it though. So this one, we would have what? It'd be the same principle. So you would have the minus 10y on the front. Right, minus 10y. And then, wait, that'd be it though. I'm just missing something somewhere, I know I am. I know I am. This has to be involved somehow, you know? But I'm not sure how. I guess what, but if you differentiate this with respect to y, you get 0, you know? Oh, but e to the power of 0 is still 1. Right? Is that what you're getting at? Is that what they're getting at, guys? I think that might be what they're getting at. And then there's the extra 1 that we wanted. Do you think that's what it is? That might be what it is. Yeah. Should we just put A? It's A or B. I'm fairly sure of that. Let's just put A. Because that question took longer than I was hoping. Question 5 is the last one. Consider this other function. Find the directional derivative in the direction of... Oh, that's a silly point, not gonna lie. And it's an easy one to do. In fact, that's the one we did at the start, isn't it? This was only difficult because it's difficult to differentiate. So then what's this one? So you would have, if you differentiate it with respect to x, you would get y cos the, right? So then we substitute in these values. They've rounded their answer, which is fine. So they're both pi over 4 anyway. Pi over 4 sine pi squared over 16, I guess. Right? And then what are we timesing that by? 3. 0.025. I think I'm in radians, guys. I mean, degrees. Yeah, that's a bit nicer, huh? 1.36. That's that doesn't help. That doesn't help at all. Oh dear. Let's try the other one then, huh? Wait, that'd just be multiplying that by 2 though, wouldn't it? 0.9? No. No. So we're doing something wrong. Should I actually read this? Because I kind of had a glance at it. Well, see, it looks like this, right? S denotes a unit vector in any given. Oh. Oh, unit vector. This isn't a unit vector. Oh. Oh. Well, now it makes sense because you know what else? That's not a unit vector either. It's not. It's not. Now, hang on. If I just go back to the last question quickly, you do minus 20, which is the answer that I got, divided by 1 plus 4, you get minus 4 over root 5. What? Huh? What? What? Huh? What? Okay, I don't think that helped. Wait. What about that? Well, I found where the over 5's coming from, huh? Wait, what about that? No. 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 I guess we just stick with the way it was before. Yeah. Sure. But then with this one, now we can actually do it correctly, right? No, we can. So. Let me go back to that sum that I had up before. I do like this. And then I times that by 3 over root 3 squared plus 2 squared. I got 0.37. You know what 0.37 is? It's not one of the choices, guys. It's not one of the choices. I think I'm working out unit vectors wrong, maybe. Do you think that's possible? Do you think that might be it? Denotes a unit vector in the given direction. What? Or maybe, wait, no. Maybe this is the direction. You need to root of that. Had you considered that? Huh? I don't know if you did. Wait, but that's not a vector though. That's just the x bit. Oh, maybe you need to work out the x bit and the y bit. Okay, so we've got the x bit. That's like 0.454. Then the y bit, well, the y bit's going to be exactly the same though, isn't it? 0.454. Right? Okay. So then, yeah, okay. So then you do answer divided by root answer squared plus answer squared, something like that. That seems stupid to me. But okay. And then what, you times that by 3? No. No. Wrong. Wrong. I'm just sort of plugging random numbers into the calculator at this point. I really don't have a clue what these directional derivatives are. Oh, this is going to be fun. You ready for this one? There's my Twitch. You're ready for this one? Is it on mute? It's not. Here we go. Where are we going? We're going to the stream from like a bit ago. Oh, here we go. Bye bye. Thank you. Wonderful. If I just a break from that a sec, we have some Getcha rolls to be doing. So let's do that. I do wonder though, what their directional derivatives are. Because they do look easy, but I'm not getting any of the answers. I'm not getting any of the answers. That's basically the issue here. So I do wonder what they mean. The numbers, Mason. What do they mean? Yes, I do wonder. But it should not be hard to figure out. It should not be hard. Do you think there's a calculator for it? Oh dear. There probably is somewhere. We could have a look. Then at least we know the right answer, even if we can't figure it out. I would like to figure it out though, to be honest. Because like I say, it should not be difficult. Been getting some nice capitals on those last balls. Up of high level, please. No particularly nice claims. No epic and cool wishes, you know? That's what we're really all about. Still no wishes. Okay. We'll come back here then. So, we've got this here directional derivative thingy. Unit vector Cartesian coordinates. Yeah, see, this is what we need. This is what we need. I know what we do, how we work this out. So we do 3 divided by root 3 squared plus 2 squared. Right? That gives us like 0.8, right? And then I can check my answer with this. Wait, hang on, we're getting there. I'm getting there. I'm typing things into the calculator. Hey, that's 1. Yeah, so that works. Right? So now we got the unit vector thingy. Right, let me just delete that. Right? So that's the unit vector in the direction. And this is u1, Now we just need to multiply this by the derivative of this. So I times that by pi over 4 sine I. It would just be pi squared over 16, right? Wouldn't it? Isn't that what we got in the first question? Yes, exactly. It's this. It's this thing here. Unless we were actually magically wrong in the first question for some reason. In which case, it would be something more like this, wouldn't it? No, it wouldn't be something more like that. It would be something more like come on, calculator. Something more like that. That gives 0.8. Which is still not one of the answers, so yeah, wasn't that one, huh? There's no point swapping these two around, because these two are both the same. They're both pi over 4, and I am now in radians, aren't I? Yeah. Oh wait. No, I know why we've been going wrong the whole time. It's because I keep putting sine instead of cos. Wait, that's all it is. Tell me I'm going to be correct now. I'm not anyway. It didn't help. It was useless. Would have been funny though. You can't lie. It would have been funny if that had been the case. Well, this has got to be A then. I know it's got to be A. It doesn't make any sense for it to be the other ones. See if there's a calculator for it. There's a calculator for everything. Let's see what the calculator for it says. Shut up. Let's see, this is all we want. Just that. Enter a point. We don't even need the Z. I just want pi over 4. Enter a vector. Was it 3, 2, right? 3, 2. Dimensions of the point and the vector should match. Really? Is that right? Oh, yeah, no, it is right. I just forgot. Yeah, just shut up. Shut up, you. Let's see what it does then. Let's see what it does. The length of the vector u. Yeah. U becomes See, this is what I was doing. That's written on my calculator that's on the screen right now. Then this, yeah, see exactly. It's this again. Ooh, to do the thing. Uh huh. Uh huh. Yeah. See, that's just this, right? What's Z? The gradient and the normalized vector. Oh, dot product day. That's something I didn't do. I think we found the missing step. I don't know where this Z's come from though. That's the only thing. Oh wait. Oh. That's because I deleted the wrong one. That's all. It's just because I deleted the wrong one. There you go, that's more like it. Now it's not quite as retarded. So yeah, we still got this. Pi over 4 cos. Yeah, exactly. See, that's what I did. Right, so you times this by this by this, and you add them together. Right, that's what I did. That's what I've got on the screen. This one is 0.33, and then if I change that to that, 0.35. So yeah, I get this as well. But look, that's not one of the options, is it? That's kind of funny, huh? This is why we're stuck on the question. The options are wrong. Look, even the online calculator can't do this one. I inputted everything right, didn't I? Sine xy, direction vector 3, 2, pi over 4, pi over 4. Yeah. And then look, see, I got the same thing as it. It kind of added them together at the end. It did kind of add them together at the end. But I mean, you can see that the answer that I've got would add to make the same answer that it's got. So I've definitely got the right one. And it's not any of these. So now we know. Now we know. Right, so which random number should we guess? We've got 1 in 4 chance. We guess the one which is closest. Probably A is closest, I guess, huh? Yeah, A's got to be closest. I don't know what they did to get their answer. I can't get any of the answers. But there you go. Let's just randomly put A. At least now I know that I can do the question correctly. So I shan't complain. Let's go hand that one in. Yep. Maths. I want this. Sure. Okay.